Hey guys, it is Dr. Ihrig here, and now we're going to talk about, is it a function? Now, on another upcoming slide, we're going to talk about domain and range. And domain is inputs and range is outputs. It's kind of like if you go to the vending machine to get a soda pop, the money that you put in is your input, the money would be the domain, and the soda that comes out would be the range. So if we look at this graphic, again, shout out to content creators. I have no idea where I got this from. Oh, I got it. Guess I got it from Matthew Cathy. Input, it goes into some kind of rule. In most cases, the rule is an equation, and then it comes out. In order for it to be a function, it has to have one input goes to one output, which means that it has to be a straight line or a parabola like this. It could never be a circle. A circle would be a relation. So there's a couple ways that you can check if it's a function. First of all, it would be, are all of the x's different? In this case, all of the x's are different. So yes, it's a function. Another thing is, however, if this was -2, and I had a -2 here and a -2 here, and these numbers are different, then in my just made up problem, not a function, because I see two -2's, okay? But I don't want to confuse us, so let's erase my pink. Okay, if you're talking about the maps, if each one of these domain inputs only has one arrow, function. If this -2 also went to 0, not a function. Again, super simple. We need every x to be by itself. And if it can be duplicated, as long as it's the same thing gets duplicated. And see here how the 4 has two x's going to it? Totally fine. We don't care about the range when it comes to, is it a function? We only care about the domains. Another thing you can do is something called the vertical line test. That's just drawing straight lines up and down. Boom. Pretend that's straight. Okay, drawing another straight line. Boom. Another straight line, boom, even though these are diagonal. But notice how these only touch the graph one time. Here, one time, one time, one time, one time. So this is a function. This is a function. Even here, if I really zoomed in, all of these would become functions. Here's an example of one that wouldn't be a function. Let's say I had a curved parabola like this. In this case, because it crosses in two spots, it's called the vertical line test, not a function. Nope. Because this x value has an answer up here and an answer out here, so it's a confused x, not a function. So you can use the graphing calculator, but really determining if something is a function is a lot easier if you just use your eyeballs. Let's take a look. 2, 4, 6. All of those numbers are different, so yes, it's a function. Look at here. Look at this 1/2. I have one arrow going to -2. I have another arrow going to 0 and another arrow going to 4. It's like that 1/2 is confused. It doesn't know if it likes number -2, 0, or 4. This case, not a function. It's a confused 1/2. Let's take a look here. Only look at the x values. -5 and 0 are different numbers. So far it's a function. But then I have a +5 and a +5. Because both of these are +5, not a function. Because this says +5 is supposed to go to 0, and this says +5 is supposed to go to 10. So those coordinates are confused. They're in a relationship, but they're just not a function, because the x coordinates are confused. Let's look at the next one. Here we have -4, -1, those numbers are different. 2, also different. 5, also different. Everybody knows who they're going to the dance with. No confusion. It's not like one person is going with 2 dates. Every number has just one date. That's it. Function. Okay, let's take a look here. Well, look at number 5. That's just like the picture I tried to draw. If I draw a line at 4, 4 doesn't know if it's supposed to be going out with 1.5, I'm estimating, or if it's supposed to be going out with 4.5. That 1, 4 has multiple people or numbers at y coordinates. Same thing for 6. All of these numbers, okay? It doesn't know. 6 is like, well, am I supposed to be going with 1 or am I supposed to be going with 5? Confusion, not a function. Now here, this is where kids are like, Doc, I know that that's not a function because the lines don't connect. The lines don't have to connect for it to be a function. The only thing that matters is every single x only has 1 point. In this case, it is a function. It's actually called a discrete function because it's point, 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 as opposed to continuous. All right, now it says what's the domain and range? And we're going to have another slide where we really talk about domain and range, but I really want to help you get this concept here. So domain are our x numbers. So let's see where our x numbers go to. Well, here there's no number, but we can tell that every 2 boxes it has a number. So this is number 1. So my domain in this set is 1, 2, even though there's not a 3, 3. Now, because these points are not connecting, I can't say that it's like 1 to 6. I have to write each distinct number because it's like 4.5 isn't in the domain, okay? The range are our y values. So I have 2 is one of my numbers. Now, I notice this also goes to 2, but I'm only going to write the 2 one time. 3 is one of my numbers. And 4 is one of my numbers. Now this one also goes to 3, but I already wrote it. This one also goes to 4, but I already wrote it. So that's my range. Domain are which x values are we talking about? So because we're doing x values, we have to look down or up to get the numbers. My range are which y numbers. So my y values, I have to look left or right to figure out what the y numbers are. Let's take a look here for this next problem. It says, what's the domain and range? Notice how these are continuous flowing. So because of that, we can put the values inside with an x. So my lowest x value is -1. My highest x value is 3. And then we just put these little babies inside. Because these circles are closed, we also are going to put the or equal to's. My range are my y values. My lowest y value is -3, and my highest y value is +2. So in this case, I'm going to have -3, y, 2. And because these are solid, I know these are going to be with the or equal to. Okay? All right, let's move on to the next slide.